Hi everyone and welcome to this video on finding a rule using anti-differentiation. Essentially this is going to be a slight extension of the last video, and what we're going to be doing now is finding out what that C value is so that we can actually determine the rule. So I've written a problem here: if dy dx equals 2x squared minus 5 and it is known that the graph of y passes through 2, 7, find the rule for y. So the first thing we need to do is we need to figure out what y is, and we get that by anti-differentiating. So y equals the antiderivative of 2x squared minus 5 dx. Now I can anti-differentiate that using the rule that we established in the last video. So raise the power by 1, divide by the raised power. So that is 2x cubed on 3 minus 5x plus c. I'll actually write y equals there as well. So we have a rule for y now, and we know that the graph passes through the point 2, 7. So I'm going to substitute those values in for x and y. So that leaves us with 7 equals 2/3 of 2 cubed minus 5 times 2 plus c. And it's just a matter of evaluating this now. So 7 equals 2/3 of 8, which happens to be 16/3, and then minus 10, and then plus c. Well, I'm just going to move everything to the other side so I can figure out what c is. So I'm going to add 10. 17 equals 16/3 plus c. I then need to take away 16/3 from both sides, but to do that I need to have a common denominator. So what I'm going to do is I'm going to just write 17 as something over 3, and in this case it's 51 over 3. So 51 over 3, which was a 17, I'm going to minus the 16 over 3 equals c. So that leaves me with c equals 35 over 3. And therefore, I now have the rule, which is y equals 2/3 x cubed minus 5x plus 35 on 3. And that is the way that we can figure out a C value. So the thing is that we need to have the coordinates of a point or some other bit of information in the question to be able to do it. Now I'm just going to leave that there for a minute as I write the next problem, but I'll come back shortly. Okay, so here we are back again. So given f dash x equals a minus 4x and f of x has a stationary point at 1, 6, find f of x. Now the problem here is that we have an extra variable in the problem. We've already got an a there. So we can anti-differentiate it, but then we're going to have an ax term, we're going to have a plus c as well, and it's just going to get really messy. So the thing is, we have to look at this question. We're going to have two variables, and so we're going to need two equations to solve it. Now, there's obviously an equation that's going to come from using the point 1, 6, okay? And that's probably what we're going to have to do, like we did in the last problem, to get the value of c at the end. But the thing is that there's another hidden bit of information in this question, and that is that f of x has a stationary point at 1, 6. Now, what that means, okay, it has a stationary point at 1, 6. So that means, well, we know that stationary points mean that the gradient is 0. So that means f dash x equals 0 when x equals 1. And so I can use that to help me find the value of a. And so that's all I'm going to do. I'm going to substitute in, so 0 equals a minus 4 times 1, which is just a minus 4, and I'll add 4 to both sides to get a equals 4. So now I know that f dash x is equal to 4 minus 4x. Then all I need to do is I need to anti-differentiate this. So I can say f of x is equal to the antiderivative of 4 minus 4x dx. And anti-differentiating that, I get 4x minus 4x squared over 2 plus c. So that is 4x minus 2x squared plus c. I might just write it in order so it's a little bit nicer. So negative 2x squared plus 4x plus c. And I can substitute in the point 1, 6. So when x equals 1, f of x equals 6. That means 6 equals negative 2 times 1 squared plus 4 times 1 plus c. So 6 equals negative 2 plus 4 plus c. 6 equals negative 2 plus 4 is just 2 plus c. And so we can actually see that c is also equal to 4. That's amazing. And so finally, f of x equals negative 2x squared plus 4x plus 4. And that is the final solution to that problem. I think I might leave that one there, and we might pick up in the next video. We'll just see how we go. So I'll see you later.